This video is on calculating the gradient at a point. So to calculate the gradient at a specific point, you substitute the value of x into the derivative expression. First example, find the gradient of the graph of f of x equals 5x cubed at the point where x equals 2. So on the graph of 5x cubed, when x equals 2, we are wanting to know what is the gradient at that specific point. So to do that, we've got two ways of doing this. The first way we're going to do is by hand. The second way is using our calculator. So to do it by hand, the first thing we have to do is find our derivative function. So we want to find what f dash x equals. So remember, for this we bring the power down, so we'll do the 5 times 3, then we minus 1 from the power, which would be 15x squared. From there, once we've got that, because we want to know when x equals 2, we sub 2 into our derivative. So it'll be 15 times by x squared, so 2 squared. And when we work that out, we'll end up with 60. So the gradient of the graph when x equals 2 on the graph of 5x cubed is 60. Now I'm going to show you how to do this one on the calculator. On the calculator, we just want to go to a calculator page. Now we go into our menu and we've got the calculus option, then we've got numerical derivative at a point, and that is the one we need. In here we put in what our variable is, which is x. The value is for the value of x that we want to find the derivative at. So in this case it was 2, because we wanted it when x equals 2. Click OK. Now in the brackets here we put our equation, which was 5x cubed. So we want to find the derivative of 5x cubed when x equals 2. Press enter and you will see there we got the answer of 60. So you are going to possibly need to know how to do derivatives by hand, but there will be some questions where you are able to do it on your calculator like this. Let's go back for example 2. So example 2, find the values of x for which the tangent to the graph of y equals x cubed plus 6x squared plus 2 has a gradient of 15. So remember, when we're finding the gradient, if we have a graph of something and it looks like this, remember that, and we want the graph, the tangent at a certain point. Remember that tangent is that line that cuts the graph like that. So we're actually finding the gradient of that line, and that's our tangent line. So in this, we've been given the equation and we've actually been given the gradient, but we want to know what is that x value. First things first, we're going to find our derivative, because we know that is the equation for our gradient. So x cubed ends up being 3x squared, 6x squared, bring the 2 down, so 6 times 2 is 12, and that will be just an x because we minus 1 from the power, and then remember plus 2 is a constant, and that just goes. Now we know that the gradient is 15, which means we know that this equation equals 15, because the derivative equation finds our gradient. And then from here we can solve that, and hopefully you'll notice here that this ends up being a quadratic, and then you can just put that into your calculator to solve, and you will find that x will equal -5 or x equals 1. Okay, so with this situation, it's actually 2 points where the gradient is 15, and that's because the graph has curves and things like that in it. And that's all we need to do on finding the gradient at a specific point.